Today we're going to continue with our discussion of the word bond graphs and how we put together a system using a simple concept that would lead us to put together more complex systems. So let's consider the system that you're seeing here. This is a system that every vehicle has. You have the battery, and then you have the starting motor, and then you have the Bendix. This is the simple system that starts your car. So in here we have the battery produces a voltage to the motor. The motor with its windings induces the rotation of the Bendix, which is a little gear that connects to the flywheel in your and the engine turns it, and then you can start the car. Okay. The point here is in this discussion is that the communication between the battery and the motor is done through this voltage and the current, those two variables. From the prior discussion, the voltage would be an effort variable and the current would be a flow variable. The motor communicates with the Bendix through the torque and the angular velocity, and that would be the torque would be the effort and the angular velocity would be the flow, right? Let me let's see let's let's see how we can apply this concept to a more complex system. In here you have a situation where if we look at the model of an entire vehicle here, which we can actually idealize on a simple diagram in here. Maybe try to see if we can actually consider. Let's go here for a moment. What I'm saying is, if we have a vehicle in here, let's say that has a motor in there, yeah, and the motor is connected to the gearbox in here, where you can actually change the gears in any way, and then it has a drive shaft, goes to a differential in here, and this thing goes to each wheel. See, each of the back wheels like that, yeah. And in here you have this is connected, let's say this way, to make it simple. Okay, this entire model, once we recognize the elements, you can actually create. So this is the motor in here, and this is the gearbox, and then you have the differential here. Alright, so if you use words, look what you can do. The engine is here, and then the clutch, of course, is here with the control, which is either connected or not connected. It's just like a stick shift car, although the automatic transmission has this clutch plus the gearbox together. And so you have this control to connect or not connect. Then you have the gearbox, and then the gearbox goes to the drive shaft, and that in turn goes to the differential in the back. The point here is, just like in the previous example, this is the idea of doing word bond graphs, is that you will be able you are able to say that the engine communicates with the clutch through producing a torque and an angular velocity. the clutch communicates with the gearbox, again with the torque and angular velocity. And the gearbox has the purpose of reducing or increasing the speed, right? And of course, when you reduce the speed, you increase the torque. When they increase the velocity, then you reduce the torque. That's the purpose here. And this through the drive shaft is another element, although in most vehicles is a circular, shaft. Um, it could have some compliance, and so that we consider an dynamic element in there. And the gearbox would go through the torque and angular velocity of each wheel, and that way we are able to build an entire vehicle, a system that's a little bit more complex than the other. I would say is quite complex um, for the entire vehicle like that. So the idea that I'm giving you here is that using words, you you can already create systems. The next step that we're gonna have to study is transforming these words into elements that actually have equations behind. Because it's nice to connect like this, but this is just an idealization. But we as engineers, we work in the mathematical world where we have to put the equations of each one of these elements and make the entire system work together. For that effect, we are going to have to study the different elements that we have in real life in here, and then transform these words into elements that the computer can understand. So that's how we do word bond graphs.